This is worksheet number 2 on gases, question number 5. When a load of M is placed on a frictionless piston shown above, the piston goes down to position 4. Find the new position of the piston when a second load of M, a new M, is applied on the piston. Now let's think about 3 conditions in this question. The condition number 1 is when the frictionless piston is at position 6, there's a pressure of the atmosphere from outside, and there is the pressure of the atmosphere inside. The two pressures are equal. The frictional piston stays at this position. In that case, P1 V1 is equal to 6 PO. In the second condition, now you put a load of M on the piston. When we put the load of M, we have outside the pressure of the atmosphere plus M. So inside the piston also, inside the container, we have PO plus M pressure. So P2V2 is equal to, and this is 4 PO plus M. In the third condition, we have now 2 loads on the piston plus the pressure of the atmosphere. So the pressure inside is equal to pressure of the atmosphere plus 2M. So P3V3 is equal to the new V, which we don't know, times PO plus 2M. According to Boyle's law, we know that P1V1 is equal to P2V2 equals to P3V3. So we can use any two equations of these two equations to solve the problem of PO in terms of M. Let's use the first two. Let's say that 6PO is equal to 4PO plus M. Then PO will come out to be 2M. Let's substitute this 2M into the second and the third equations and solve the two equations again as P2V2 equals to P3V3. So 4 times 2M plus N, 3M, is equal to, again instead of PO I write 2M, 4M times the unknown volume. In that case, 12M is equal to 4M times V. V will come out to be cancelling the M's and simplifying 3. So the new position of the piston will be at 3 when 2M loads are applied on the piston. This is worksheet number 2, question number 3. A certain amount of air is trapped inside a tube with the help of a 10 centimeter high mercury. The height of the air in the tube increases from 35 centimeters to 45 centimeters when the tube is turned upside down. Find atmospheric pressure in centimeters mercury. Now let's analyze both diagrams in detail. In the first diagram, we have the pressure of the atmosphere making a pressure downward. Let's call it PO. And it is balanced by the pressure made by the mercury, which is making a pressure downward, the liquid pressure, and the pressure of the gas inside the tube. Let's call this P gas 1. So P gas 1 is equal to pressure of the atmosphere, PO, plus 10 centimeters mercury, which is the liquid pressure of the mercury trapping the gas. In the second diagram, we have the pressure of the gas inside the container when it's turned upside down. It's making a downward and all directions but downward pressure. Let's call this P gas 2. P gas 2, as it's making a downward pressure, this is balanced by the pressure of the atmosphere, which is inside the tube and making an upward pressure, and the pressure of the mercury, which is always due to gravity making a downward pressure. So P gas 2 this time is equal to pressure of the atmosphere, PO, minus 10 centimeters mercury. What are the volumes for P gas 1 and P gas 2? For P gas 1, the volume is 35 times the base area. For P gas 2, the volume is 45 centimeters times the base area. Now we can apply Boyle's law to this question because the temperature and the number of moles are kept constant. So P1 V1 is equal to P2 V2 in the diagrams. P1 is PO plus 10 and V1 can be called 35 centimeters mercury times the base area. The base area is cancelled, so I'm not going to write it. P2 is equal to pressure of the atmosphere minus 10 times 45. If we solve this question, we will find that pressure of the atmosphere will come out to be 80 centimeters mercury.